Thank you. Yeah, so I'm Chris Butler, Director of AI, which is a very kind of hyped up term right now, but I'm originally a product manager of about 18 years, and I've done both product management and business development. So Philosophie, I'll talk about that a little bit later, but we're basically a small design consultancy, and so we do a lot around kind of product design, prototyping research. And what we're going to talk about today is really how to build trustworthy AI products. And there's a bunch of questions that I want to go through while we're talking today. And so the first one is really just what is AI? So I'll give you a quick 5-minute intro to that. What is trust in general? How do we actually, what does trust have to do with machines? And I'll tell you a short story about that from my personal experience. And then how do machines build trust with humans? Then finally, we'll talk about what's the right level of trust, because it's not just about gaining as much trust as you can get. And then finally, what techniques can we actually use to understand what's the right level of trust, how to build trust, what are the right ways to kind of foster that relationship. So what is AI in 5 minutes? I really like this description of data science, machine learning, and AI because these are the main terms that are being used right now. And this is by David Robinson, who's the chief data scientist at DataCamp, which if you ever want to do online courses around machine learning, data science, it's a really great place to do that. It's pretty cheap, too, for a monthly rate. And I do not get paid by them, just to be clear. But data science is really meant to be about how do we actually understand, how do we produce insights about something within the world. Machine learning is about how do we then find predictions or predictive capabilities from that data. And then artificial intelligence really just comes down to taking action or making a decision. So this is an easy way I think of it. Now, generally, when you're talking about building a product of some type, you're going to use, if you are using AI in this particular case, you'll actually be combining all of these things together. So you'll very rarely see that there's just decision-making capability without insight or prediction capability, because that's something that humans use to be able to take action. Now we talked at the basics. I want to talk a little bit about what it is not. What AI, machine learning, and data science isn't. Okay. So first of all, it's not all chatbots. Everybody that works in AI now has to build a chatbot and then fail at it. So it's not just chatbots. There's a lot of other ways that you use these different technologies. It's not magic fairy dust that you can just sprinkle over a product and suddenly it's more intelligent. It's not the singularity or Terminator that's going to kill us all. It's not her. It's not this type of, like something you'll fall in love with, at least not right now. And then finally, or not finally, but this is something I think is so funny, is that there seems to be this like weird blue and black color palette and like sparkly brains and like white robots with human faces and things like that equals AI and machine learning online. And this is not it either. This is probably a very bad analogy actually for what AI is. And then, we talk a lot about in the world of AI about this concept of human in the loop. And this is usually where there's one machine that is interacting with a human, and it's that loop of kind of making decisions alongside a machine. I'm going to go into this a little bit later, but it's not as simple as just that human in the loop anymore. It's not just one machine and one human. So what is it, right? If we're going to talk about data science, this is data science, pretty graphs. Right? In this particular case, it's a data set about irises that's used a lot in the beginning to talk about whenever people are learning about data science. This is a way around kind of unsupervised clustering of different iris types based on petal length and petal width. That's all data science is. It's about trying to make an understanding or an insight out of a big set of data. When we talk about machine learning, this is machine learning. Okay? And so all this is doing is this is pulling in some data about how to do basically training a model around square footage in relationship to housing cost, okay? And this is the part that's really important right here, is this idea of, so here's the data, here's the training of the model, here's the prediction, and there's the output. There, machine learning, ta-da. So it can be way more complicated than this. The models that can be used can be way more complex. They can take days and days to train, but this is essentially what machine learning is. And then, there's a special type of machine learning which is called deep learning, and the only difference between neural networks and today what we call deep learning is really just that there's a lot more stages within this neural network than there was before, okay? And when we talk about neural networks, how many people are actually familiar with what a neural network is? Okay, well let me talk about that for a second then. So basically neural networks, it uses the analogy of the way brains work. It's just the analogy. It's not exactly the way that brains work when it comes to the individual neurons. And so what it has is it has a bunch of inputs that come in, and then it uses what's called weights and biases between all of these different linkages. And there's a calculation, and there's an output. Okay? And so that's all a neural network is it's basically a way to do multiplication and addition across this set of nodes in this graph. And so deep learning, before, it was very hard to calculate very, very large-scale neural networks. But because of graphics cards, because of big data, we're finally starting to be able to train these types of networks that are not even, this is considered to be very small. But we're talking about tens of layers that, with millions of neurons, can actually be trained up to do very impressive things. But that's deep learning in a very, very small nutshell. Next is what I'll call artificial intelligence, which is really just decision making. And what this is this is a visualization of how to win at tic-tac-toe no matter what, or to tie at least. And so all that is it's just, in this case, it's just a plan, right? It's a plan that's been pre-calculated by a computer and then put into a visualization of how to do that. But that's all AI is that it's always meant to be this thing that is what humans can maybe do right now that machines couldn't is usually what AI has been considered to be. But in the end, it's really about like, how do you allow machines to help make decisions or make decisions in some automated way? That's all it is. Now, what I think when we talk about the idea of what is the right analogy for machine learning? You remember all those sparkly brains and like the white robots? I actually think it's closer to this idea of an ecosystem niche. So in this case, this is the dung beetle, which because of its environment, because of the other types of insects and animals that are around, it's evolved to have a very unique thing, which that it collects dung, and it actually is able to read the stars to understand which direction it is. That's another thing altogether. But it's a very specific niche. And this insect is meant to be in that niche within the environment. And I think as we start to talk about how machine learning, AI work within products, it's no longer just this idea of like some all-knowing, omnipresent intelligence. That's not what it is. It's more about tiny machines that exist within an ecosystem of, say, an organization or a social network or something like that. So I think that's a better analogy, is kind of insects within an ecosystem. And then the other thing I would say is that because we're starting to talk about networks of people, this is actually a visualization of Star Wars and all the different characters and how they interact with each other. And I like this one because it actually includes androids in this case. So like R2-D2 and C-3PO within this network, right? And so it's, when we talk about our actual organizations, we have, say like a business, we'll have a network of people that are interacting with each other. And a lot of the times there will be intermediaries that are software. So that could be email today, that could be documents. But in the future, it could be very narrow intelligences that are helping provide, say, predictive capabilities, certain types of visualizations. And so we're really thinking about the overall like organizational network with intelligences overlaid on top of it. And I think that's probably the better way to think about this than just one human and one computer interacting with each other. So that's kind of AI in a nutshell, and I went really fast. You're going to have to read a lot more to actually dive into this more deeply. But when we talk about from a product context, this is really like a lot of other technologies, right? Like product people shouldn't actually know all of the things about, say, how a web page is made. They should know some of the trade-offs, and they should be able to have that discussion with their engineers about trade-offs. But that, I don't think diving much deeper is always helpful. And so what I do think is important, though, is what does it mean to be more human-centered around AI? And so, at my work, we do an awful lot around design thinking. We do a lot of lean and agile. And those things kind of intersecting talks a lot about how do we build things for people. And so if we bring this definition set up again, when I think about this from a human-centered standpoint, it really is, data science is about insights about people, right? Machine learning is about predictions for people to use, not just for no reason. And then finally, artificial intelligence is really about producing actions to help people. And if there's no human purpose that's behind any of this, then it doesn't really matter. And I want that to be very clear. So let's talk a little bit about trust. Oh, by the way, and I'll be posting all the slides online if you guys can't keep up on this. Sorry, I talk very fast. But what is trust, right? So I've read a lot of different papers, not only in trust in automation, but also just trying to discuss what the social implications of trust are in general. And probably the most succinct way to think about trust is that it really helps facilitate cooperative behavior. So when we talk about within a culture, we have certain types of norms, and that allows us to meet for maybe the first time and then transact in some way, maybe in a cooperative way, so that we can get something done. And that's really what trust is about, right? Is that type of thing. And I tried to gather at least what I think the main factors of trust are, how to really define trust just in general. And so one of them is that it's kind of a contract. In some ways it's written. So if we have a contract between two people or two organizations, you'll believe something about that kind of relationship that you wouldn't have otherwise. But there's also unwritten ones. So when we talk about cultural norms or the way that different cultures display and have trust with each other, that's very important. Trust is always about some expectation for the future, not for the past, right? It uses the past as data points to look towards the future, but it's always about what I think someone will do in the future or how they'll react to me or how they'll help me. And then, performance, accountability, and transparency tend to be very important aspects of trust. So performance is like, am I doing something that's valuable? Am I doing something that I'm saying I'm going to do? Accountability is that if something goes wrong, how am I at fault for that in some way? How do I take care of problems that come up out of that? And then transparency is that, do you understand why I'm thinking the way I do or why I'm taking action? And how do you build models about the way I do things? And this builds slowly, but it can be lost very quickly. Right, so that's kind of my overview of trust. And a good example of how trust works in today's world, especially in the US, is around kind of patient and doctor trust. So there's a lot of baggage that comes with this, both good and bad. Right, so there's good stuff that doctors within the United States, at least, and I'm sure it's different worldwide in some subtleties, but doctors go to school for a long time. They have an ethical oath that they all take. And so we believe certain things about the way doctors, when they're communicating with us, how they will deal with us and how they will give us information. But it's also interesting that this is very much like a human consulting something like a machine learning algorithm that may know or be able to recognize patterns the human couldn't, right? Is that the doctor knows an awful lot about the way biology works, but they don't necessarily explain everything they understand to the patients that they have. What they do need to do, though, is they need to give them enough information to be able to make decisions, sometimes life or death ones. And so I think that's a good way to think about the way that trust works, is that there's expectations going into some type of relationship, and then there's an ongoing thing, that if a doctor continues to push for decisions that you don't believe in, you will then start to lose trust with that particular doctor. But there's kind of an initial trust that happens there. So what does trust have to do with software, right? This is actually from a company that I ran about 5 or 6 years ago called Complete Seating, and it was an open table competitor. And our focus was actually, how do we help managers and hosts basically operate their restaurant in a more effective way? And we used a lot of what we called back then analysis or analytics, business intelligence, and some prediction, and then basically constraint programming, which if I was raising VC today, it would have been restaurants powered by AI would have been the tagline. But we would basically help a host make the experience of actually getting a guest from walking in to sitting at their table as smooth as possible. And a lot of what we do, and this is an example of one of the screens, we were using Bootstrap. We were not designers at that point, so it's very bare bones. But what we were able to do is, because of the way we had built this algorithm, we could do some very interesting things. So we could, for one, start to predict when a walk-in could be seated. And so in some cases, that could be right now, and we'd tell them which table it could actually go to. In other cases, for larger parties, for example, this restaurant didn't have any availability based on the combination of reservations, wait list, and the people that are currently seated. And then the other thing we could do is that when we talk about the individual reservations here, we could start to plan out the entire night automatically. And so when a host would have to do this, it would take 5 or 10 minutes to be able to plan out a night. We could do it in a couple hundred milliseconds. And so we could keep doing it over and over again. And so that's where the difference is. In this case, the locks meant that the host actually locked that table in. The ones where there's no locks, that meant that we just generated that based on the algorithm. And so the issue was, though, one of the many reasons why we failed. One of them was that hosts did not trust our algorithm. And the reason why was that they didn't know why it was working the way it did. It didn't always know why it made decisions the way it did. It was something where, because we were in beta at the very beginning, there were errors or there were bugs, right? And so we burnt a lot of the trust up front when we were trying to work with these hosts. And so I think that's something that is just so visceral for me, is that when I was working on this company, I was staging in a restaurant at least once a week as a host. And so seeing their real concern about, this thing is messing up my capability to run a restaurant effectively, was really visceral for me. And so, anyways, I just want to make sure it's clear. Like, it does matter that people trust your software, that they trust your services, they trust your apps. And so, how do machines actually build trust with humans? And so, looking back to the performance, accountability, and transparency, I think there's a couple key points here. So we're on performance, right? When we talk about machine learning in particular, there's a couple common performance measures. And so, accuracy, precision, recall, F1, which is a ratio between those. This is really that for an algorithm, when it takes in a bunch of information and it spits out some type of prediction, how accurate is it based on the reality of the world or the truth that we're understanding, right? And so you can get into cases, though, where accuracy can be very high, but it can actually be bad experience. And accuracy can be fairly low, like, say, in the 40 to 50% range, but the experience is pretty good. And so this is not necessarily a good way to think about this. The next one is what's called the confusion matrix. And so I stole this from human-centered machine learning, bless you, from Google. And so this is called the confusion matrix. It's used a lot in data science and kind of statistical, just like the statistical field. And what it means is that at the very upper left-hand corner, it's that the prediction that the system makes is in alignment with what the reference or the truth of the world is. So it means that the machine learning algorithm says that it should do something, and the truth is it should do something. And so that's a good thing, right? That's called a true positive. If it says it shouldn't do something, and it shouldn't do something, that's called a true negative. Now, where we get into some trickiness is really around the false positive and the false negative. So false positives are that it thinks it should do something and it does something, but it shouldn't have. So that could, and then the opposite is false negative, which is that it doesn't think it should do something and it should have. So let's take an example of like an autonomous vehicle. So let's say that there's an autonomous vehicle that has some type of sensing apparatus to detect if someone is in front of the car or not. And if it detects that someone's in front of the car, it slams on the brakes, right? So in the case of a false negative, is that it would think that there's nobody in front of the car, but there is, and it hits them, right? So that's really bad. The false positive in that case is that it thinks that there is someone in front of the car, but there isn't, and so it slams on the brakes, and it's not as bad, right? So that's the difference between that. But it doesn't always mean that false negative or false positive is worse than the other. It depends on the circumstance. You could imagine that in the case of, say, doing certain types of X-ray analysis, you could find that a false positive that you think there's a cancer there would cause a lot of kind of costly procedures that could be cause a lot of other health after effects, right? Whereas a false negative, not detect it, but maybe the occurrences are so small that overall the false negative is less of an impact to the entire population. So that's another very important performance measure. But I think what's interesting about all these things, and I think this is partially a problem with just technology in general, is there's this kind of rule or heuristic that every number is either 0, 1, or infinity. And what that means is that really either there's a lack of something, there's one of something, or there's just lots of something. And so what this means, and I think the reason why this is a little bit of a problem, is that when we talk about things like accuracy, even just like raw numbers of, when we talk about, say, monthly active users, daily active users, it makes the assumption that we should go to infinity with monthly active users or daily active users. There's never a time that someone just says, actually, this is enough daily active users, right? And this is really important because when we talk about how, what this means, in this case, Reed Hastings, during one of his calls, I think it was a year or so ago, started talking about how the main competitor for them is actually sleep, right? And that's probably a bad thing for people in general. There is kind of a current movement about wellness within technology. Google just talked about this at their Google I/O and how they start to make people more aware of the amount of time they're on of an actual device. And so I guess that's all I'm saying is that when we talk about performance measurements, a lot of the time with machine learning, it's about perfection towards some type of truth. But the reality is that it should be more about what is better for the humans that are involved. And so this is more like the law of medium numbers, which comes from systems thinking. And so it's the idea that, yes, there's very small numbers, and that's something where we do a particular type of modeling. And then there's like large numbers like thermodynamics, where we do averages of things. But the things that get really tricky and are kind of like where the squishiness is in the system is the human beings. And that's usually that middle range of numbers where it's not as easy to just understand very basic modeling versus the idea of like very large modeling. So I think that's very important. There's a talk, Shane Lewin, who is part of Microsoft now, at the O'Reilly AI Conf, which was just like about a month ago. During his talk, he said something that really resonated for me, which is that this optimization function, which is really whenever we talk about machine learning is about trying to reduce the amount of error between what it thinks the world is and what the truth is of the world, and that's called an optimization function. And what really matters, though, is that the optimization function is your strategy in that case, because whatever you're trying to error correct towards is what you're going to put all of your resources behind within your organization, and you really want those things to be aligned with whatever is human in that case. The next thing is accountability. So when we talk about accountability, so this is a really awesome GIF where this driver realizes that they missed their exit. Don't worry, I think the other car is going to stop too. So they made their exit, thank God. The thing that's interesting about this is that if that was an autonomous vehicle, right, that autonomous vehicle did not get into an accident. But it did cause other accidents, right? And so when we talk about this type of thing, there's a great paper called Moral Crumple Zones. And so I think one of the issues around accountability, especially with machine learning and AI right now, is that it's very hard to determine where that problem is. And when we talk about moral crumple zones, is that generally the operator of the system is the one who takes fault. So this is, in the case of autonomous vehicles, Japan has regulation that anybody who gets into an accident within an autonomous vehicle, it's on the onus of the driver and on their insurance, for example. And so that puts the crumple zone on the human being, even though there were developers, there were manufacturers, there were all these different people. And I think what's really special, what's really important about this is that when we talk about accountability is it's actually, it's a very tough issue, but we need to in some way understand what that means when we're building these types of systems. This is another example. This is a Thurrock 25, which is a machine that would give chemotherapy doses to people that have cancer. And unfortunately, due to a bunch of kind of factors at the same time, so a mechanical problem, there was a problem with the way that error messages were displayed, there was a particular software bug. All of those three things together meant that about 4 or 5 people died of overdosing with radiation. And so what ended up happening is that between versions of this, the operator would say to put down a dose of radiation, and it would give back an error message that made the operator think that the dosage had not been given. But there was a mechanical lockout that was changed between 2 versions, and there was a software glitch that then was exacerbated by that. And so when we think about like accountability, we have to do a much better job, I think, of understanding and maybe taking accountability for the systems that we actually build, right? And so this is another great paper, if you want to read it, around accountability in computerized society. And so, this is something where I'm not sure what the right answer is. I think, as we try to make good decisions or try to build ethical systems, we should be taking this on. But I also think this is where things like GPRD, for example, are trying to address, especially with privacy, but I think there's that's the reason why the FDA exists. I think we're going to see more and more of this type of regulation because it is unclear who is at fault in that case. Was it the hardware manufacturer? Was it the programmer? Was it the operator? And this was, so it's a very complicated issue, but it's one that I think is really important as we start to talk about trust with computers or automation. And then transparency. And when we say transparency, it really means how does the person understand what the machine is doing, right? How do they build mental models about what the machine is doing? And so a lot of that is actually user experience or user interface. So here's a couple things that I've looked at. And so this is from a particular project we worked on around field service operations. And field service operations is if someone, a field tech, needs to go on site to say like fix a refrigerator or something where they have to go somewhere to fix something. And so in our case, it was actually gas stations. And then there's a dispatcher that helps organize all of this work for field techs. And there's a lot of other people that are involved. But in this particular case, we were building something called Patrick, which was originally a chatbot, which failed. But then we started thinking about how do we help out these dispatchers and the way that they actually do their work. And so in this case, this is an explanation that is put in line to kind of a job workflow tool on why Patrick made a particular decision about scheduling a particular tech. And so this comes down to what's called interpretability. So how is it that I'm able to build a mental model about the machine that I'm working with? And so it doesn't matter actually what the machine does. It doesn't even matter what the original designer of the system means it to do. It's what the person thinks it does that really matters. So these mental models around interpretability are very important. And I think there's a little bit of kind of maybe some terminology, pedanticness that I go through around this. Like there's a lot of discussion about explainability within machine learning today. But I think it actually doesn't matter what the machine learning algorithm actually does. It's more about how does the human understand that and then make the right types of decisions based on that information. The next thing is what we'll call like intelligent or adaptive call to action. So one of the things that a machine learning algorithm or an AI system can help with people is that they can push them in the right direction towards what types of actions should they take at this point based on the knowledge of the system, of the state of the system. And so in this case, we had a particular area that really talked a lot about, for this job, what is the next step? And so there were a lot of different things that you could do. You could schedule the job, you could start to order parts for it. And so it was trying to make sure that the right type of offer or option was being given to the actual operator in that case. The next thing is abstractions. And so as we start to build more and more complex systems, it really comes down to that the way that the person understands the world today, they need to find better ways to understand the world. And maybe that's a little clunky. When I say abstractions, I mean right now when we think about, like, say, insight from data science, it's usually building graphs so that I can have a better understanding around something. When we talk about abstractions, it's how am I understanding the way the world is, but then also taking action on it in some way. And this is an example that's from the New York Times that tried to show why certain types of policy decisions within the MTA has caused a lot of delays in the subway. And so the thing that's really interesting is that once you learn how to read this, you actually can start to play around with different policies and see how it impacts this. And so this is essentially each one of these gray lines and the colored ones are basically, it's one subway going at normal speed is the gray line. When it gets delayed, the orange one I think is delayed because of spacing issues, and then red is delayed because of some other problem I can't remember right now. But at the end, as you are tweaking these different variabilities of policies, it becomes very complex. So even policymakers in that case did not necessarily know how they would impact the actual subway system based on the policies that they were using. And so in this case, this type of abstraction, once you start to learn and become an expert on this type of abstraction, you can make very interesting decisions about minimizing problems and maximizing the benefit to other people. And so these abstractions, I think, as people, and this is where there's something called like the paradox of expertise, in that as machine learning and AI starts to take over more and more of the jobs that experts do, they'll have less and less expertise. And so the question becomes, how do they become experts in these new abstractions that allow them to do things that are better than they would have been able to do previously? The next thing is generating options. So we talk about machine learning is not always kind of binary in the sense that it has one option that is the best, the right option. Now, there may be one option that is considered to be the best option by the system, but there's actually multiple options that are potentially generated. There's multiple probabilities that are calculated in some way. And so being able to provide more information about why this option, so it's a little bit of interpretability, but then also offering the capability to switch between the different possibilities that the machine learning algorithm has can be really effective to make the human being even better at their decision making. One of the things that machine learning will do is and this is meant to be fuzzy because I made a mistake on my slides. And if you have to tell a joke, if you have to describe a joke, it's probably not a very good one. But in this case, a machine learning algorithm can actually detect what is maybe standard. That's what they're really good at. They're good at generalizing patterns. And so they can see things like anomalies that are maybe human mistakes. This also means things like bias, right? Even though machine learning has the possibility of amplifying bias in certain ways, it also has the capability of potentially detecting bias, because bias is an anomaly that maybe doesn't generalize. So that's another thing that I think is really important when we talk about how that kind of transparency with the system is, that the system thinks this is wrong, is really important. Next one is illusion of control. So I don't know how many people have realized this, but probably the thermostat in your office probably doesn't work. And it's probably not connected to anything. Same thing with elevator close. I think in New York, elevator close buttons actually do work, but in like California, they just never seem to work, right? The reason why is that those buttons or those dials are put there to make you feel like you have some control over the situation. It makes you feel better, but you actually don't. And so this is maybe a weird one because there's a lot of maybe potentially ethical questions that come up around this, is that how do we make people feel better about using these systems, even though the choices that they're given are maybe not real, right? Like this is maybe an example of where, my dad was a graphic artist, and so he would, this is back when we'd actually do like tissue paper and like actually print out things to show them off to people. And he would always have, if he gave, say, 3 options, he would always have 2 of the other options he didn't like had really major errors in them. So like there would be like misspellings, or there would be like a line that was clearly off kilter in some way if it was supposed to be straight. And so the illusion control was really like, oh, these other 2 are really bad. I don't know why you even showed them to us. You know what I mean? Like we're going to take this one that is the right one. So I wonder, like playing into human biases can be a good thing because it can help us do a better job. That's why like things like nudge, if anybody read that, this idea of like how do you use human biases to actually get them to make better decisions for themselves. Of course, there's the question then is like, who are you to decide what's the right decision for someone? So there's a lot of ethical questions around that. Next one is really being upfront about errors. So one of the ways that you can lose trust between a machine or automation and a human being is that if the machine makes really simple, stupid errors, the human being is much more likely to just not trust them at all. But if they make really complex errors that are hard for the human to understand, they're more likely to give it a break. So this idea of like being upfront about certain types of errors, being better about detecting your own errors, or when there's low confidence, being upfront with that from a machine standpoint can be really helpful to the human being to adjust their expectations around this. And then, allowing intervention or appeal is really important, right? We talk about how these systems and all the different people that are involved that are affected by these types of machines, if you don't allow them in some way to disagree or to escalate or appeal these problems, you get some really bad situations. So a good example of that, I think it's in it's like Michigan and Idaho. They're now doing benefits, basically for Medicaid through certain types of rule-based systems. And so there's a real issue where people would get certain benefits adjusted down because this new system was put in place. So like hours of assistance, for example. And they disagreed with it. And even the people that were there talking to those people that were beneficiaries of this disagreed with the calculation. And they ended up having to take those companies to court to actually get them to even look at the logic. And it seems like most of the time the logic was actually just faulty, and that the rules were not implemented correctly. They were coded incorrectly. And so this idea, in this particular case, it was that we were automatically assigning field text. It's not as bad as, say, benefits for Medicaid, but that's the issue, right? Is like if you don't allow humans to actually intervene in some way, you're going to be causing a lot more harm. And especially if you're not taking into account everybody that's impacted. So probably the people that built these systems really just cared about the operators. And when I say the operators, I mean the people that are running it at a state level, not the people that are actually there helping people, and not the people that are actually receiving those benefits. And then finally, feedback, right? So one of the most important things you can do is you can have the machine learn from people, right? In this case, if in our particular prototypes, if the dispatcher decided to change the field tech that was assigned, we would ask why. Because there may be other things that we're not understanding in the system, we're not collecting that we should be to be able to make that decision better in the future. So now we talked about trust. Let's talk about what is the right level of trust, right? Because you can actually trust things too much. And so use is really just this idea that I will turn on the automated system, I'll utilize it, and I'll turn it off as appropriate. And that's really all it means, is that I'm just going to use the system in some way. When we talk about misuse, it means that I trust it too much, and I will actually depend on the system in cases where I shouldn't, right? So a good example of that is in the case of, say, Uber with the fatality. That safety driver was not actually paying attention in the way that they should have necessarily. They trusted the system too much, right? And this is from Ayanna Howard, Dr. Ayanna Howard down at Georgia Tech. And so she did this experiment where she invited a bunch of students. She had them fill out some paperwork and then simulated a fire in the building and then had these robots that were teleoperated try to guide these people. And the thing that was really interesting is this robot would try to guide them into this cluttered room. It would circle around in a room over and over again. It would knock into walls. And people still trusted it. An alarming amount of the time, people trusted that machine so much that they would just follow it around. Now, you could say that maybe they didn't simulate a hazard experience as well as they could have. But I think the key point here is that in this case, there was too much trust put in this robot. And maybe even having a robot was the wrong choice here. That instead of having a robot that seems very official, that it knows what it's doing, have like emergency glow-in-the-dark tape on the bottom of the ground so people can then take action. I mean, this is something where, a lot of the time when there is a fire, people are not stressed enough now to get out of the building, right? So generally in the ICU, if anybody's ever had the unfortunate experience of being there, there's these racks of machines, in this case that's giving medication. These are a bunch of different sensors, that's some type of monitoring gear. All of these things give alarms, right? And if they did a calculation where every ICU nurse had to deal with something like 10,000 alarms per day per patient, right? And I don't know if you've ever been in ICU, but like the first time I ever heard one of those alarms going off, I was like, what are we supposed to do? And I was like calling the nurse to come by, and they're just like, oh, it's fine. And they just like turn it off, right? And so this shows that in some way this automation that's in place is not trusted in any way, and it's actually maybe not valuable. So that's disuse. And then finally, abuse is actually when the people that are the designers of the system or the owners of the system don't take into account the actual operator's needs. And so they believe that it should be in a certain way, or they believe that, in the case of that Medicaid benefits, they didn't take into account the actual person that would be getting the benefits on how they could interact with that system. In fact, there was no way for them to interact with that system. And in this particular case, like when we talk about design thinking, and this is Stanford's D School breakdown of design thinking, where we empathize or understand more about the people we're trying to build things for. We define what the problems are, we ideate solutions, we prototype solutions, and then we test them. We kind of do this over and over again. When you talk about the abuse scenario, that means that you're just cutting out this entire empathize section. You don't even care. You're not going to talk to the people that are going to be using the system. You're just going to build it the way you think is right. And that's what the problem is, I think, with a lot of automation. So what techniques can we start to use to learn about trust for these problems and solutions that we're building? And so one of the ones that I think is really powerful and really important is problem interviews. So how many people have done qualitative research before where they've talked to their users? Okay, all right, so good handful of people. Quantitative is definitely important. I don't know, I tend to, because we do things that are so early stage in our business, we tend to focus on qualitative research most of the time. When we talk about problem interviews, it's really trying to understand like what are the issues that a person has in their life or in their function that you're trying to understand more about. But there is some nuance, I think, when we talk about machine learning and how we understand trust. So trust is really interesting for me because I almost think about it that the machine is someone that you're trying to train up in the job for the first time, right? And so some of the questions, these may be questions you already ask. I think these were a slight difference in the way that we would start to ask these questions, like, what stories do you tell people about how your job works usually? Understanding things like heuristics. Tell me about a time in the past that things didn't go right. Like, what did you do? In those particular cases, that helps you understand that when the machine will make a mistake, like what is the actual, how does that work within the organization? Is it a really big deal? Is it not a big deal? And that starts to help you understand and break apart what is the trust within that organization itself. How do you explain your understanding to someone else? How do you draw it? And this is meant to be kind of a conceptual activity. So how do people build these mental models when they're trying to convey information to other people about a potentially very tricky circumstance? What is the key information that they need to convey? What are the mental models that they use to start to think about that? And so there's a really interesting story about a mathematician that would do some very like arcane kind of mathematics research around, I think it was like convex holes or something like that. And so in this particular case, he would draw circles and then lines or parabolas going in and out of these circles, basically. Because it was a mental model that he was able to use to understand conceptually what it meant to actually build these types of convex holes when he was thinking about the theory. Einstein did this with space-time, right? So there's always these mental models that we have, and how are you getting those from the people that are actually doing this job on a regular basis is really, really powerful. Because it could be very related to the abstraction that you'll create within your interface, but could also be the terminology that they use. That's really helpful. How do you cobble together solutions to get what you need done? So one of the things around machine learning and kind of just automation in general is it's this, especially like robotic process automation, which It just seems like a crazy term to me. I don't know why it's still being used, RPA, but because there's no robots involved anymore. It's just software. But the idea is that there's all these different tools that I have to touch on my desktop to say, do intake of a customer support complaint. And I have to copy information from here to there. So there's a lot of things that I need to do that could just be automated, right? And so I think that's something that's very interesting. And this maybe gets to also, we talk about job to be done as a framework. That idea of understanding what is the solution that can help bridge other solutions is really important. And then, how have people built trust when working with you? How is it that you actually trust other human beings that they're going to do their job properly? What are the signals they give? What are the assurances they give? What type of information do they provide up front? And so these are all questions to try to attack or interrogate this system in the way that they do their job on a regular basis. The next thing is prototyping. And so this is the prototype that we put together for the field service operations. And so you can see here, this is about one particular job. There's a call to action about what I'm supposed to do. There's some recommendations and predictions that are being given by the system. There's a chat between the dispatchers and field techs, but also Patrick, who's this bot, is adding to that conversation. They're automatically including people, thinks that should be assigned. It's doing automatic scheduling, a bunch of other things like that. And so this, though, wasn't actually a built system. It was really just sketch prototypes that were put in Vision. We created a couple different scenarios, but we ended up testing, do people actually trust what's going on here? Do they understand what's going on here? We also did some things around affinitization I'll get to in a second. Or sorry, kind of their sentiment about it as well. So there's two prototyping styles I like to think about when we talk about machine learning. So the first one is Wizard of Oz. And so Wizard of Oz is where you basically build a facade of a system, but there's a human being back there. That's the whole point of Wizard of Oz. But in this case, one of the ways that you can understand whether a machine could do it is, can a human even do it given enough time, right? So we assume machines can do things faster than us. They can find maybe certain types of generalizations we can't find. But if there's just no way for you to even understand what information you would need to make a decision to do something, then you're probably going to have a very hard time building a system that would do that. So Wizard of Oz is basically, from a prototyping standpoint, you build some type of, say, web interface or app interface. There's some interface for a person on the back end to gather that information, to do something, and then respond back to the person. But this is based on the assumption that they don't actually know that it's a human being back there. So you can start to understand different trust issues around that as well. I think that's really valuable. And the next one is a concierge approach. And so this is the opposite of that. So in the forefront, you actually don't have any interface other than maybe email or chat or phone, but it's a human being talking to another human being to understand things. But then you're building tools on the back end to actually automate a lot of the processes that the human being is doing. And so that's where you can start to learn what pieces of this can you automate, what are the cobbled together solutions today, that type of thing. And this is some really interesting work being done by Wendy Ju at Cornell. She was at Stanford. She does a lot of work right now with automotive, and in particular, she actually doesn't build machine learning systems. She doesn't build AI systems, but she does a lot of work. Some of her stuff, I don't know if you had seen it, but some really interesting work around automated trash cans on the Stanford campus, right? So this trash can would see someone had trash and would kind of wiggle up to them and shimmy a little bit to signal that it wanted trash from them. And none of that was built out as an automated system. It was actually, again, it was a puppeteer in the background kind of controlling this. There were cameras. And they understood how people started to feel about space with these robots. They started to understand, kids were trying to bait the robot into following them with trash and things like that. So a lot of interesting interaction possibilities were starting to be understood, but it was all just through basic kind of robotics that were teleoperated. And in this case, when we talk about their Waze system, is that it's a system that sits in a car that's trying to act like an assistant, or in some ways, I think, as an autonomous vehicle type of thing. But all of it is done actually by an operator that can see what the person is seeing, and they type commands or have hotkey commands that will then be spoken through Alexa, essentially. And so they're testing something that would be like a real automated system within a car, but they didn't build any of it yet. And I think that's really valuable. Being able to understand whether something actually meets a problem or solves a problem for someone is way more valuable than wasting time. And in the case of, say, machine learning, data scientists, for example, they will say that about 80% of their time is just cleaning data, and the other 20% of their time is actually just complaining about cleaning data. And so I think gathering all that data, cleaning it, training a model over like 9 months, and then finding out that it doesn't matter, like that's bad. So you should do this way earlier than that. And then user interviews. Once you do have a prototype, how you start to talk to the end users and understanding how they would react in different circumstances is really valuable. And this is maybe where there's the nuance, right? Like we still, generally I think whenever we do usability testing, for example, we do a lot of, I think a lot of people end up getting fixated on what would be called the happy path of the usability. But it's really important to test a lot of different scenarios. And so in this case, the correct operation is just that the machine learning algorithm of the AI works the way it says it would. It seems seamless. It just works, right? But you should also be testing, like, what does it mean for incorrect operation? Do people actually understand that it's incorrect, right? And there's ways you can do this that are harder to orchestrate and easier to orchestrate. But really you should be getting to this point, like, are they intervening when they should, right? Both sides of the borderline for misuse and disuse. And what I mean by that is that, is there a case where if they trust it too little and they don't use it, that it's bad, right? Like, but that they're trusting it. So like, where is it on the opposite line of trust that they are? So yeah, let me try to explain that again. So is there a case where they should still trust it, but it seems really shaky? That's the borderline on the right side of trust. Is it a case where they should not trust it, but they do, right? That's another side of this. So trying to understand those like edges of the experience and understanding from the human is really important. Feedback from the human to the machine, like when something does go bad, what type of feedback do they want to give? What is the right kind of analysis that they're doing around that? And then state communication, so just are the abstractions making sense? Are they building the right mental models in the human? So there's a bunch of information, that I tend to ask, and these tend to be, again, trying to be as unbiased as possible, trying to be as open-ended as possible. And in the end, like when we talk about trust, like we may formulate it in certain ways, but people just think about, they have their own definition of trust, right? So actually probing whether they trust something or not, and what does that mean to trust something is pretty important. And this was some interesting research we did where we, after doing some prototyping, we actually looked this scale is actually from negative sentiment to positive sentiment, and then not understanding to understanding what the machine is doing, okay? And we started to cluster things in the sense that things that were down here, like where they didn't understand whether they liked it or they didn't, it meant that we were doing a poor job in the user experience. We were doing a poor job explaining, the interpretability wasn't there. There was some problem that we needed to address. In the upper right-hand corner, these were things where they feel really happy about it and they understand what's happening, and that's a good type of automation. Those are the things that you should immediately start to think about, like how do we build models or train models to do this type of predictive capability. And then the upper left-hand corner were things that they knew what it was doing, but they were not happy about it. And generally that was around job security issues. And so like, is this going to take over my job in some way? And I think what's interesting here is that you probably, even though you could maybe do those types of things better, there's a couple different options, right? You could decide that it's maybe not worthwhile because you want to provide the effectiveness of a human in the rest of these cases where they still feel good about. It could be that you provide things like the illusion of control. What I always worry about is when we talk about machine learning and AI, people are overly fixated on just automation rather than augmenting the way humans do their work. And so in this particular case, these ones, maybe we need to go back and understand, are we actually attacking the problem in the wrong way? Are we aiding them in the wrong way? So in conclusion, using AI is just like any other technology. I mean, there's definitely nuance, and so you should be aware what those nuances are, but you need to be able to like have those discussions of trade-offs. You should build for the right amount of trust, and that means not too much or too little. And then, trust is really based on a trifecta of performance, accountability, and transparency to the human. So I work for Philosophie. We do a lot of AI strategy coaching. We do hackathons or facilitation of hackathons. We do what's called Balanced Team, which is really a product team to build AI solutions. And then finally, a lot of workshops. So if you want to talk to me for 30 minutes for free, just give me your business card and we can talk. Thank you.